All right, so when we have a graph and we're supposed to find the average rate of change between 2 points, it's very similar to what we were doing before, where we identify this is my first x, that's x1, and this is my second x, x2. And what we need is essentially a corresponding corresponding y1 and y2 that goes with those. If we wanted to, we could actually use the slope formula if we identified what our y1 and y2 are. You could, because we're given the graph, actually count the rise and count the run, which is part of the strategy that's kind of inferred by saying go ahead and plot a line segment by clicking on two locations. So what we're supposed to do is go to the x line, the vertical line of -8, which is right here. This is x equals -8. If you look at the x-axis, you'll see that. And on this vertical line, you see that the graph touches it right there. So essentially, that's the coordinate we're playing with. We could actually name it the y1 right there, this y height. Be careful, it's counting by twos. If you look at the y-axis there, the y-axis grid lines are going to change. It's not counting by ones. That happens in math books and this generator. It's just a thing to watch out for. So this is 2, a y1 of 2. Essentially, the coordinate we're working with is -8, 2, if we want to use coordinates to count using the slope formula. The second coordinate, -6, if you go to the graph here, -6 is the x bar I'm looking for. So this is x equals -6. And we go on that vertical line all the way down here, and you see that there's a dot right there. Okay, so that coordinate, you see it hits a y height of -4 here. So that's -6, -4. So I could have short-circuited the process here of not doing the graph and counting. I could just use these two coordinates like I've done before to find the average rate of change using the slope formula. But this problem is nice because it's getting us that visual connection to make meaning out of what the average rate of change is. It's asking us to click it in two locations. So click the dot here, and when you do that, you get this line attached to where you just clicked, and we're supposed to drag that over here to the second dot, and you click it. And what just happened is we got a nice little, if you look at it really close there, you get a nice little rate of change representation by a nice little line. So the idea is that we're supposed to be able to count the slope there, just seeing that it goes down 1, 2, 3 boxes, but be careful about counting the boxes here because we saw on the y-axis it actually counts by twos. So 3 boxes down, 1, 2, 3 is actually counting down 2, 4, 6. So this is a rise down of 6 and then a run of 2. So that's that's the intention of this problem, is for you to be able to count like that. But again, be very careful because the y is counting by 2. So down 6, -6, and then a run of 2. So my slope would be -6 over 2. And then we go ahead and reduce that to be -3 would be my result for this problem. And then down in the box, it actually asks a little bit more details. It says, what's the change in y? And so with the line that you actually made, what they're looking for is the unreduced, not -3. They're looking for the unreduced down 6. So this is the change in y. So this delta y, I went down 6, goes in that box. And then the run, the delta x, is how far to the right you went, and that's the 2 that goes here. So this, again, this delta y is rise, and the delta x is run. Delta means change. And then the average rate of change takes essentially the delta y and divides it by delta x, which we did just a moment ago, the -6 over the 2. And then that answer that goes in the box here is -3. All right, in this second example, similar to the first, we're asked to go from 3 to 8. The 3 is my first x value, x1. The 8 is my second x value, x2. And we weren't given y heights. We're supposed to find them from the graph. So we want to pay attention to the y-axis again. Notice it goes 0, and the first line is 10. That means we're counting by 5s. So to keep that in the back of our mind. I want to go ahead and find the x line of 3, which is right here. This is x equals 3. And so on that vertical line, you identify where the graph touches that vertical line, right there at that coordinate. That's my first dot that I'm going to click here in a second. And then 8, x equals 8, would give me this vertical x line, and it touches the graph right there. And so those are the two dots that I'm going to connect. So now I click one of the dots first, and then notice again, you get a line that is attached to your mouse after you click it, and then you attach it over here at 8. And our job, again, is to now look at that line and identify what's the rise and the run. So you could just zoom in and count it. Notice it goes up one box, but that one box counts as 5 boxes, and then it runs 1, 2, 3, 4, 5 boxes. So the answer for slope, the rate of change, is going to be rise 5, run 5 is divide that to be 1 is the average rate of change answer. But we're supposed to do a little bit more analysis than that because we're supposed to separately answer what's the delta y and the delta x. So I'm going to do that. The change in y, the delta y, is equal to 5 because I went up 5. The delta x is how far you run from here to here. The delta x is also 5. So I put this 5 in this box, this 5 in the second box, and then the average rate of change is always delta y over delta x, and that should give me 5 divided by 5, and I reduce that to get my answer of 1. So one final note as you're finding average rates of changes on different problems, if you have a dot to dot and you get that trend that you're going up, make sure that you have a positive slope result. If you end up getting, you just connect your dots and you see pretty immediately that you're trending downward, if you're trending down, make sure you get a negative slope result. So just on different problems, these aren't the lines for this particular one, but on various problems that you roll through, a quick check to know if you're getting a correct answer is just whether or not it's positive or negative. If your line was going up from left to right or going down from left to right, you get positive or negative slope respectively.